April 8th. Yeah, to most of us, it's probably just another day. But in the world of math, this date is huge. It's monumental, and I'm going to show you exactly why.
So what's the big deal? What could have possibly happened on this one day that still echoes in our world today? I'm talking about everything from the calculators in our pockets to the very classrooms we learn in.
You see, on this one single date, but across different centuries, some truly brilliant minds completely reshaped our world. So let's meet them.
All right, first up, we're heading back in time, way back, before computers, before smartphones, to a time of gears and pure ingenuity. No, seriously, just think about it for a second. Before you could just whip out your phone and tap in some numbers, how on earth did anyone, businesses, scientists, engineers, do really complex calculations quickly and, reliably?
Well, the answer takes us right back to our special date, April 8th, 1925, and it introduces us to a man named Frank Baldwin. Now, this was the day he passed away, but boy, did he leave behind an incredible legacy.
Okay, so here's the deal with Frank Baldwin. He invented one of the very first reliable calculating machines. His big idea, his innovation, was this compact pinwheel cylinder thing, and that was a total game changer. It meant his machine was way smaller and more dependable than the clunky, error-prone gadgets that existed before. It brought some much-needed mathematical order to the chaos of business. Later on, he helped create the famous Monroe calculating machine, and that thing became a staple in offices everywhere. Basically, all the work he did laid the foundation for the pocket calculators and even the computer apps we all just take for granted today.
Just let that sink in. Every single time you calculate a tip or check your grades on your phone, you're really tapping into a legacy that started with his mechanical genius. Kinda cool, right?
All right, we're still on April 8th, but now we're going to jump forward just a few years to meet our next pioneer.
So for our next story, we're going to look at something that actually changed the classroom itself.
Okay, this next one is a big one. Have you ever heard someone say that boys are just naturally better at math than girls? For generations, that was a super common belief. It was an idea that held millions of people back. So where did that even come from? And, more importantly, who was brave enough to challenge it?
You guessed it. The answer takes us right back to April 8th, this time in 1928. It was the birthday of a truly remarkable woman named Elizabeth Fennema. So Elizabeth Fennema didn't just argue against this idea, she tackled it scientifically. She was a pioneering researcher in math education, and she actually helped develop this tool called the Fennema-Sherman Mathematics Attitude Scales. Its purpose? To actually measure how students felt about math. Her research was groundbreaking. It used cold, hard data to cut through all that chaotic noise of prejudice. And what did she find? The achievement gap? It had nothing to do with gender. It was all about attitude, encouragement, and opportunity. She proved that with the right support, anyone could be great at math.
I mean, think about the impact. Her work completely dismantled a harmful myth. It reshaped education and opened doors for millions of people, all by proving one simple, powerful truth. A great mind has no gender.
So there you have it. Same date, just 3 years apart, and a totally different kind of revolution. See? One date, so many stories. But we're not done yet. Let's keep going.
For our final April 8th story, we're going to go a little more abstract. We're diving into the beautiful, hidden patterns of the universe itself. So what do the perfect patterns in a snowflake, the structure of a crystal, and even the fundamental rules of physics, what do they all have in common? I mean, they all share this deep underlying mathematical property. But what is it? Well, the answer lies in the work of a brilliant mathematician named Graham Higman, who passed away on, you guessed it, April 8th, 2008.
Higman was an absolute master of a field called group theory. Now, I know that sounds kind of intimidating, but don't worry. All group theory really is the mathematical study of symmetry. So think about a square. You can rotate it 4 times, right? Or you can flip it in 4 different ways, and it still looks exactly like the same square. Group theory is just the set of rules that describes all those moves. It's basically the language we use to talk about all the ways something can be changed, but still appear the same.
And Higman's work in this area was just profound. He developed these powerful new tools to understand these hidden structures. He was even a key player in this massive project to classify all the finite simple groups, which are basically the Lego bricks of symmetry. And here's the craziest part. His super abstract work has found stunning real-world uses. It helps physicists understand the fundamental particles of the universe, it helps chemists understand how crystals are structured, and it's even a cornerstone of the encryption that keeps all our data safe online. How cool is that?
Basically, he found the hidden rules that govern the universe's patterns.
He gave us a brand new way to see the deep mathematical order that's hiding in plain sight, all around us.
Okay, let's step back. We've got an inventor, an educator, and a theoretical mathematician. I mean, on the surface, what could possibly connect these three?
Every single person we've met today, Frank Baldwin, Elizabeth Fennema, and Graham Higman, they're from different centuries, different fields, but they're all connected by this one date, April 8th. But it's more than that. They were all driven by the same fundamental human curiosity. They were all, in their own way, asking the same powerful question.
What is the pattern hiding inside the chaos? Think about it. Baldwin saw a pattern in mechanical gears to solve the chaos of calculation. Fennema saw a pattern in data to challenge the chaos of prejudice. And Higman? He saw the patterns that govern the very structure of our universe. Because they all dared to ask that one question, our world is more logical, it's more equitable, and it's more deeply understood. So that leaves me with one last question for you. What hidden patterns will you look for today?